Okay, hey there everybody. I am making a little Snagit screen capture tutorial for you guys about sigma notation. This is the section 4.5 in the book. Please read through it. It's part of our whole unit on sequences and series. Alright, here's the problem. What if a teacher wants to get his or her students to add up the first 30 multiples of 11? How would the teacher communicate this on a test or a quiz to the students? Well, you could write it out as you see below here in 11 plus 22 and so on, or you could simply write it out in words. But even better, let's come up with a mathematical symbolic language that can do that. You could invent your own system of abbreviations, but math people from around the world got together and invented sigma notation. So it looks something like this. All right. That last question, we're adding up 30 numbers. We start with the first term, and we're going up to the 30th term right there. And this is our explicit notation. All right, so easier for you to take notes doing it this way. N is the variable. It's our index number that helps us count through how many terms we have. So when n is 7, it doesn't mean that there's a value out there in the number sequence that appears as a 7. It just means the 7th term. Okay, this is always the explicit formula. It could be arithmetic, it could be geometric, it could be some weird hybrid, it could be some invented thing, but it's going to have an n value that when you want to find the 30th value, you simply plug 30 in for n and it gives you the 30th value, so it must be explicit. All right? So let that sink in, and I'm about to give you a challenge here. How do you write the following sequence in sigma notation? Sorry, the top of those letters got chopped off. My aim wasn't so good in the screen capture. But we're going to add 2 plus 10 plus 50 plus 250 for another 16 terms to make a total of 20 terms. What type of a sequence is this? Well, it's not arithmetic. I'm definitely not adding 8. So try geometric. Am I multiplying? 2 times 5 would give me 10. 5 times 10 does give me 50. 5 times 50 does give me 250. So it should be pretty simple to check and see what type of a sequence it is. This is geometric. So I just need to be able to count for a total of 16 terms with my geometric formula. Alright, let's see what that is then. You can pause and try it on your own. Here's the answer though. And don't ask me why, but I'm getting, there we go. The answer is counting from 1 to 20 will give me the 20 terms, and then this is the formula for a geometric sequence. There's my first term. I'm multiplying by multiples of 5. I've got that n minus 1 thing going on because I've already been given the first term there. Okay? So see if it works. Plug in 1 in for n minus 1 is 0. 5 to the 0 is 1. 1 times 2 would give me 2. Alright? If I plug in 20, it'd be a great big ginormous number. You can try on your calculator. Alright, so here's the challenge for you. It's pretty straightforward. You can read through in the book if you have any questions. But bring this problem. You don't have to solve it. I don't need to know what the sum is. We'll go over that later. But I want this written in sigma notation to our next class. Alright, good luck with that.